Thinking about space and the stars above is a topic that inspires awe in many people. Maybe it inspires you so much that you want to study astronomy and make it your full-time job. Perhaps you know that astronomy and astrophysics research is a blend of physics, math, chemistry, and computer science, or maybe you are yet to find that out. Whatever motivates you, do be prepared for the fact that most people will think you write horoscopes when you tell them what your major is. First off, what's the difference between astronomy and astrophysics? Well, especially for the purpose of an undergrad degree, there really is no difference. Most people will use the words interchangeably. Astrophysics may technically study more of the physical processes relating to space, but both subjects involve physics, so I'm just going to say astro from now on. To get an astro degree, you will probably start off taking courses that cover the basics of physics, maths, and computer science, plus a couple of specific astro courses covering stellar evolution, the Hertzsprung-Russell diagram, exoplanets, galaxy structure, interstellar dust, Hubble's law, dark matter, and dark energy. This shouldn't be too hard if you've done any reading or independent research on the subject. Even more so than physics, astronomy attracts people who are really passionate about the subject from a point of interest rather than job marketability. So you probably know a bit about these subjects already. Moving into higher years, you will cover astronomical imaging, usually through a hands-on course where you use computer programs such as DS9, MATLAB, and Python to process images, apply filters, perform astrometry, which is measuring positions of stars, and spectroscopy. This is where you will really start to see the benefit of taking computer science courses. Astronomy involves a lot of data, and it's not very useful to you unless you know how to manipulate it. Additional astro courses might go further in depth about topics like nucleosynthesis, which is how elements are created, or solar system astronomy, cosmology, which covers the Big Bang and origin of the universe, astroparticle physics, neutrino astronomy, planet searching, or even gravitational waves. How much you get to do depends on which uni you're at. Where I did undergrad, there were only a couple of higher level astro courses. And truth be told, that even though I took some astro, I ended up majoring in physics and math instead, because those were the subjects that were really the grunt work behind the astro topics, and I was more interested in them. You will not be able to do astronomy without some solid knowledge, also in linear algebra, classical mechanics, nuclear physics, particle physics, orbital dynamics, and differential equations. And unlike some astro ideas, these topics are harder to teach yourself as sort of a side hobby. There are plenty of cool opportunities for the astro major. A big one is working in research and working in any of the amazing observatories all over the world, either as a scientist or a technical staff or an outreach coordinator. Since you'll have math, physics and comp science skills as well, you can also work for companies that need someone technically minded. You could develop scientific software or electronics and optics systems. You could work in science communication, management, or as a patent agent, like Einstein. One thing you won't be doing much of whilst studying astronomy is looking through a telescope. You might do that for fun with your friends, but professional astronomy uses huge telescopes that record data straight onto CCD cameras, and then you are sent the data to process. You could be a successful astronomer without even using a telescope. If you do want to use an instrument for yourself, then get prepared for some field trips, pulling all-nighters to gather data. It's an exciting time in the astronomy community.